Welcome to the module of What Works Clearinghouse, or WWC, Single Case Design, or SCD, Standards Training, focused on determining study ratings for studies that are eligible for review using the Single Case Design Standards. On the slides, some words are underlined and in bold. Definitions for these terms are in the glossary, which is available on the WWC website, whatworks.ed.gov. If you haven't done so already, please view the introduction video before viewing this module. The introduction reviews important background information about this training and describes accompanying resources. You can access all the resources mentioned in this module through the WWC website, whatworks.ed.gov. This module describes the WWC standards for reviewing single-case design studies and explains how the WWC assesses the standards to determine the study rating. After completing this module, you will be able to describe the WWC standards for assessing single-case design studies that are eligible for review, and you will be able to apply those standards to a single-case design study. Before we discuss the WWC's current standards for reviewing single-case design studies under version 4.1 of the WWC Standards and Procedures Handbooks, it is important to recognize several important changes that occurred between versions 4.0 and 4.1 of the handbook. Beginning with the current version of the handbooks, version 4.1, the WWC uses a fixed effects meta-analysis approach to synthesize evidence of intervention effects, including evidence from single-case design studies. In contrast, under prior versions of the handbook, the WWC used a modified vote-counting approach to synthesize and characterize intervention effects. Because of this switch to the fixed effects meta-analysis approach, the WWC now calculates impact estimates from single-case design studies using design comparable effect sizes, or DCES. As we will discuss later in this training, the design comparable effect size permits characterization of intervention effect sizes using a metric that is comparable in other between-group study design types, such as randomized controlled trials and quasi-experimental designs. Thus, under version 4.1 of the Standards and Procedures Handbooks, when possible, design comparable effect size estimates are calculated for single-case design studies that meet WWC single-case design standards, and those effect size estimates can be synthesized in fixed effects meta-analyses alongside comparable effects estimates from other group design studies evaluating effects of a given intervention. This change from a modified vote-counting approach to a fixed effects meta-analysis approach under version 4.1 of the WWC handbooks means that the WWC no longer needs a separate procedure for determining intervention ratings for single-case design studies. Thus, under version 4.1 of the handbooks, the WWC no longer conducts formal visual analysis to characterize the findings from single-case design studies. This also means that under version 4.1 of the handbook, the WWC no longer uses what was previously called the 5-3-20 rule, which previously stated that single-case design studies could only be included in a WWC synthesis when those studies were rated meets WWC pilot single-case design standards, and when there was at least 5 studies available from at least 3 non-overlapping study teams that contained data for at least 20 cases. Thus, prior to version 4.1 of the handbooks, single-case design studies rarely contributed information to WWC intervention reports that synthesized evidence on a given intervention's effectiveness. But now, under the current version of the WWC handbooks, the move to a fixed effects meta-analysis approach for synthesis, alongside the adoption of the design comparable effect size for quantifying intervention effect magnitude in single-case studies, means that single-case design studies can be included in more WWC intervention reports and syntheses, which is a promising improvement to ensure evidence from these rigorous designs are reflected in characterizations of intervention effects. What does this mean for how the WWC uses visual information? Under the current version of the handbooks, version 4.1, WWC reviewers no longer perform a formal visual analysis process to arrive at an intervention rating. Although WWC reviewers no longer perform formal visual analysis as part of a WWC review, visual information presented in primary studies is still important. This information can help reviewers determine whether a study meets other aspects of the WWC single case design standards. This visual information can also assist WWC topic area leadership in making determinations regarding whether and how to calculate the design comparable effect size. Finally, reviewers will document visual analysis in the study review guide under author-reported findings, which we will discuss later in this training. Now that we highlighted the recent major changes to the WWC single case design standards, we will now provide an in-depth discussion of the WWC's standards for reviewing evidence from single case design studies. The WWC's single case design standards are based on 5 primary determinants. We will briefly mention each of these 5 determinants here, and will provide more depth on each of these in the remainder of this module. The first requirement in the WWC's single case design standards is that raw data from the study must be made available in neither graphical or tabular format. Second, the independent variable in the single case design must be systematically manipulated, with the researcher determining when and how the independent variable conditions change. Third, for each case, the outcome variable must be measured systematically over time by more than one assessor. Later in this training, we will provide more detailed information related to considerations around inter-rater reliability. Fourth, if applicable, the study should be free of residual treatment effects. Fifth, and finally, the study design must provide at least 3 attempts to demonstrate an intervention effect at 3 different points in time, with a sufficient number of data points per phase. These 5 primary determinants of the WWC's single case design standards are encapsulated in Figure 4.1 on page 82 in the WWC Standards Handbook, version 4.1, which we have reproduced here. This flow diagram provides a quick and easy reminder of these 5 determinants, so this figure is a useful tool to have on hand when you are conducting WWC review of single case design studies. Having now briefly summarized these 5 primary determinants of the WWC's single case design standards, we will now discuss each of these in greater detail. Recall that the first study rating determinant for single case designs is that raw data from the study must be made available in either graphical or tabular format to allow for visual inspection of the data. Here you can see an example of how such a graph or table might appear in the original single case design study report. If graphical or tabular data are not available in the original study report, but the study would otherwise meet WWC single case design standards, reviewers will draft an author query to request the raw data. As with the other design types eligible for WWC review, such as group designs or regression discontinuity designs, the WWC will submit author queries to request missing information that could change a study's final WWC rating. It is important to note here that single case design researchers almost always present raw data in graphical format, meaning that most single case design studies will easily satisfy this requirement. Recall that the second study rating determinant for single case designs is that the independent variable must be systematically manipulated, with the researcher determining when and how the independent variable conditions change. Thus, the key consideration here is whether the researcher was in control of when the intervention took place. To meet this requirement, the researcher could still consult with other individuals on the timing of the intervention, including teachers or school administrators. However, the researcher should be the one ultimately in control of systematic manipulation of the independent variable. Otherwise, if teachers or administrators are the ones who chose when to introduce or withdraw the intervention, then this would not be considered systematic manipulation by the researcher. One important point to note here is that WWC reviewers should provide study authors with the benefit of the doubt when applying this standard. If the study report does not provide explicit language about systematic manipulation, but there is reason to believe from context clues in the report that the researcher was likely the one manipulating the independent variable. Thus, if there is no compelling evidence to suggest that the researchers were not in control of when the intervention took place, WWC reviewers can provide study authors with the benefit of the doubt, unless there is compelling evidence to suggest otherwise. Nonetheless, if this is unclear from a study report, then WWC reviewers should check with topic area leadership to determine whether any assumptions made by the reviewer are reasonable or whether an author query may be needed to request more detail from the primary study author. Recall that the third study rating determinant for single case designs is that the outcome variable must be measured systematically over time by more than one assessor, which is often referred to as the inter-assessor agreement requirement. More specifically, and as outlined in the WWC Standards Handbook version 4.1, there are 3 criteria that must be met in order for a single case design study to meet this requirement. First, study authors must collect inter-assessor agreement data at least once in each phase of a design. Second, the study authors must collect inter-assessor agreement data for at least 20% of the data points in the baseline condition, as well as for at least 20% of the data points in the intervention condition. Third, the assessor agreement data must meet minimal acceptable thresholds. The WWC currently defines those minimal acceptable thresholds as greater than or equal to 0.80 for percentage agreement measures, or greater than or equal to 0.60 for Cohen's kappa inter-assessor agreement measures. There are a few important clarifications regarding the inter-assessor agreement requirement that deserve mention. First, as outlined in the WWC Standards Handbook, the inter-assessor agreement data must meet those minimum acceptable thresholds for each outcome measure, across all phases and all cases, but the inter-assessor agreement data do not need to meet those minimal thresholds separately for each case or each phase in the design. Second, author queries should be conducted if the authors do not report enough information to assess whether the outcomes meet the inter-assessor agreement requirements. It is important to highlight that many single-case design studies may not meet this inter-assessor agreement requirement if study authors do not provide a clear description of how inter-assessor agreement data were collected. In our experience, we have found that researchers often provide the needed information to determine whether inter-assessor agreement reliability estimates meet minimal thresholds. However, many researchers may only provide a vague description of whether inter-assessor agreements were collected in each phase, and for at least 20% of data points in each of the baseline and intervention conditions. If it is unclear whether this inter-assessor agreement requirement is met, and the study would otherwise meet WWC single case design standards, reviewers will draft an author query to request additional clarification. Again, the WWC submits author queries to request missing or incomplete information that could change a study's final WWC rating. Recall that the fourth component of the WWC's single case design standards is that, if applicable, the study should be free of residual treatment effects. Residual treatment effects occur when the effects of intervention in one phase are carried over into subsequent phases in the design. So residual treatment effects are typically only applicable in alternating treatment designs where there is a rapid alternation between multiple intervention conditions. Residual treatment effects might be present in other single-case designs, such as treatment reversal or withdrawal designs when an intervening third condition is present, although the timing of phases in these designs typically mean residual treatment effects are not a concern. According to the WWC single case design standards, if both the content expert and WWC reviewer both agree that residual treatment effects are likely in a single case design, then the study is rated does not meet WWC SCD standards, because the measures of effectiveness cannot be attributed solely to the intervention of interest. When evaluating whether residual treatment effects are likely in a design, these decisions should not be focused on the patterns of data within an individual single-case design study. Rather, the WWC content expert and reviewer are expected to make this determination solely based on domain knowledge expertise or previous evidence regarding the outcomes and interventions of interest, combined along with knowledge of the timing of phases and observations. Given this reliance on content expertise, rather than empirical data from the study at hand, content experts must be involved in this process. Thus, WWC reviewers who have any concerns about residual treatment effects should document those concerns in the study review guide and flag these concerns for further review by topic area leadership, including the review team content expert. Time for your first knowledge check in this module. Researchers are observing students in several special education classrooms in a single school district, repeatedly measuring the percentage of off-task behavior in 20-minute windows throughout the week. The school district decides to implement a new special education curriculum to improve student attention to academic tasks, staggering implementation timing due to limited training resources. After the school district implements the curriculum, the researcher decides to use a multiple baseline design to continue observing students' off-task behavior to document the effects of the curriculum as it is introduced in classrooms across the district. What is the highest possible rating this study could receive? Your choices are: A. Meets WWC SCD standards without reservations. B. Meets WWC SCD standards with reservations. C. Does not meet WWC SCD standards. You may want to pause the video now to think about your answer. The answer is C. The highest possible rating this study could receive is does not meet WWC SCD standards. In this scenario, although the independent variable may have been systematically manipulated by the researchers did not determine when and how the independent variable conditions change. Rather, the school district made the determination of when and how the independent variable conditions changed. Thus, the highest possible rating this study could receive is does not meet WWC SCD standards. Knowledge Check 2. In a multiple probe design with 3 participants and 5 observations per phase, the authors state, in total, across all 3 participants, 5 of 15 observations in the baseline condition and 2 of 15 observations in the treatment condition were independently double-coded. Coders were graduate students who observed the participants. Reliability was checked using Cohen's kappa with an agreement of 0.70. What is the highest possible rating this study could receive? Your choices are: A. Meets WWC SCD standards without reservations. B. Meets WWC SCD standards with reservations. C. Does not meet WWC SCD standards. You may want to pause the video now to think about your answer. The answer is C. The highest possible rating this study could receive is does not meet WWC SCD standards. In this scenario, the researchers collected Inter-Assessor Agreement, or IAA data in each phase and in each condition, and the Cohen's kappa value of 0.70 was larger than the minimum threshold value of 0.60. The proportion of Inter-Assessor Agreement data assessed for agreement in the baseline condition, namely 5 out of 15 baseline sessions, or 33%, was sufficient to meet standards. However, the proportion of Inter-Assessor Agreement data assessed for agreement in the intervention condition was only 13%, or 2 out of those 15 baseline conditions, and thus is not sufficient to meet standards, which require that Inter-Assessor Agreement data be collected for at least 20% of sessions in each of the baseline and intervention conditions. Thus, the highest possible rating this study could receive is does not meet WWC SCD standards. Recall that the 5th study rating determinant for single-case designs is that the study design must provide at least 3 attempts to demonstrate an intervention effect at 3 different points in time, with a sufficient number of data points per phase. This is labeled the 3 demonstrations criterion in the standards. There are 2 elements to this 3 demonstrations criterion. First, the criterion requires that the single-case design includes at least 3 phase transitions. Second, this criterion requires that the single-case design includes an appropriate number of observations per phase or condition, depending on the type of single-case design being employed. As described previously, the bottom portion of Figure 4.1 in the WWC Standards Handbook provides a quick summary of how the 3 demonstrations criterion is defined for each of the single-case design types eligible for WWC review. In short, if a single-case design meets the other requirements of the WWC SCD standards, then the study receives a final rating based on the number of phases and/or observations per phase contingent on the design. As a reminder, Multiple probe designs are considered a special case of the multiple baseline design, and changing criterion designs are reviewed using the reversal or withdrawal design criteria. Of note, in some cases, WWC topic area leadership may determine exceptions to these standards, and in that event, any exceptions to these standards would be described in a review protocol. For treatment reversal or withdrawal designs or changing criterion designs, a design must have a minimum of 4 phases per case and 5 data points per phase to be rated meets WWC SCD standards without reservations. To be rated meets WWC SCD standards with reservations, reversal or withdrawal or changing criterion designs must have a minimum of 4 phases per case and at least 3 data points per phase. And finally, any treatment, reversal or withdrawal or changing criterion design with fewer than 4 phases or fewer than 3 data points per phase will result in a rating of does not meet WWC SCD standards. Again, the only situation in which this criterion would not apply would be in cases where WWC topic area leadership documented an exception to these standards in the relevant review protocol. This figure displays findings from an example treatment, reversal, or withdrawal design that included 2 baseline phases and 2 treatment phases during the implementation of a function-based intervention. The outcome in this example is the percentage of on-task time, which was measured at 20 unique time points. For this design, the highest possible rating this study could receive is meets WWC SCD standards without reservations, given that this treatment reversal withdrawal design includes 4 phases per case, namely 2 baseline phases and 2 treatment phases, and this design includes 5 data points in each of those phases. Thus, according to the 3 demonstrations criterion, the highest rating this study could receive is meets WWC SCD standards without reservations. Moving on to alternating treatment designs, the 3 demonstrations criterion states that alternating treatment designs must have a minimum of 5 data points per baseline or intervention condition, and at most 2 data points per phase, in order to be eligible to be rated meets WWC SCD standards without reservations. According to the WWC Standards Handbook, when applying this standard, any number of consecutive data points from a single intervention, without any intervening data points from another intervention, are considered a phase in an alternating treatment design. Alternating treatment designs must have a minimum of 4 data points per baseline or intervention condition, and at most 2 data points per phase in order to be eligible to be rated meets WWC SCD standards with reservations. And finally, any phase based on more than 2 consecutive data points per phase will result in a rating of does not meet WWC SCD standards unless topic area leadership has documented an exception to this criterion in the review protocol. This figure shows an example of an alternating treatment design with 2 treatments of interest. A contingency management intervention condition, what we will call CM, and a contingency management plus functional behavioral intervention condition, which we will call CM plus FBI. This alternating treatment design includes 8 phases. The first CM phase occurs at time 1. The second CM phase occurs at times 4 and 5. The third CM phase occurs at times 7 and 8, and the fourth CM phase occurs at time 10. The first CM plus FBI phase occurs at times 2 and 3. The second CM plus FBI phase occurs at time 6. The third occurs at time 9, and the fourth phase occurs at times 11 and 12. Thus, the CM condition in this alternating treatment design has 6 data points, and the CM plus FBI condition also has 6 data points. Thus, because this alternating treatment design has a minimum of 5 data points per condition and has no more than 2 consecutive data points in any phase, the highest possible rating this study could receive is meets WWC SCD standards without reservations. Moving on to multiple baseline and multiple probe designs, the 3 demonstrations criterion requires that these types of design include a minimum of 6 phases, with at least 5 data points per phase in order to be rated meets WWC SCD standards without reservations. To be rated meets WWC SCD standards with reservations, multiple baseline or multiple probe designs must have a minimum of 6 phases with at least 3 data points per phase. And finally, any multiple baseline or multiple probe designs with fewer than 6 phases or fewer than 3 data points per phase will result in a rating of does not meet WWC SCD standards. However, there are additional criterion that govern the WWC rating of multiple baseline and multiple probe designs, which we will review here. All multiple baseline and multiple probe designs are subject to 4 additional WWC review criteria. These additional criteria reflect essential features for internal validity in these types of single-case designs, which focus on ensuring that comparisons can be made both within and across units within the design. Namely, these additional criteria assess whether the timing of the design's implementation ensures a degree of concurrence when the intervention is introduced across cases. These 4 additional criteria are that 1. All cases must have baseline data collected prior to the administration of the intervention for any of the cases in the experiment. 2. The data must be organized in a manner that allows for the data to be compared vertically. For example, data from one case can be compared to data from another case at approximately the same time point. So if the design includes data for 3 cases, Mike, Judy, and Ramon, this requirement states that data must be organized in a way that could potentially allow us to compare Mike's time 1 with Judy's time 1 and Ramon's time 1. 3. If appropriate for the design, training phase data must be present. Namely, if the intervention is expected to have an effect immediately upon its application, then data must be gathered during any training phases described by the researcher. Interventions where the impact is expected to have an effect only after training is complete may have empty training phases and still meet this requirement. 4th, and finally, cases still in the base phase must continue with baseline measurement at or after the time point when a preceding case receives its first intervention probe, or after training sessions if those are present in the design. So in other words, baseline data collection must continue at or after the time when a preceding case receives its first intervention probe. Let us look at several examples and apply the 3 demonstrations criterion and the 4 additional multiple baseline or multiple probe criteria. This figure displays findings from a multiple baseline across context design that included 6 phases, 1 baseline phase and 1 treatment phase per case, and a minimum of 3 data points per phase. If we then assess the 4 additional multiple baseline or multiple probe criteria, we see that first, baseline data were collected in the baseline phase for each case prior to any case receiving the intervention. Case 1 had 3 data points in the baseline phase, Case 2 had 5 data points in the baseline phase, and Case 3 had 7 data points in the baseline phase. Second, we can determine that the data presentation is indeed organized to permit vertical comparison across the 3 phases, since the figure clearly demonstrates that the timing of the first data point happened on the same day 1 for each of the 3 cases. Third, we see that data collection began immediately upon receipt of the intervention for each case. Fourth, we can confirm that cases still in the baseline phase continued baseline measurement at or after the time point when a preceding case first received an intervention probe. For instance, Case 1 first receives an intervention probe at time 4. Both Case 2 and Case 3 continue their baseline measurements and at after time 4. Further, when Case 2 first receives an intervention probe at time 6, Case 3 continues their baseline measurements at and after that time 6. Thus, this multiple baseline design meets all 4 of the extra criteria for multiple baseline or multiple probe designs. And because this design includes 6 total phases with at least 3 data points per phase, the highest possible rating for this study would be meets WWC SCD standards with reservations. Here is a second example, which involves a multiple baseline across context design that includes 6 phases, 1 baseline phase and 1 treatment phase per case, and a minimum of 3 data points per phase. If we then consider the 4 additional multiple baseline or multiple probe criteria, we see that first, baseline data were indeed collected prior to the intervention being administered for any case. Second, presentation of these findings shows an example when the data are organized in such a way that vertical comparison across cases is not possible. Namely, data collection for case 1 occurred between December 1st and December 10th. Data collection for case 2 occurred between January 3rd and January 12th, and data collection for case 3 occurred between January 15th and January 24th. In this example, data cannot be vertically compared across cases, because the x-axis in the graph clearly indicates that data collection occurred at different times for each of these cases. Thus, even though this multiple baseline design meets the 3 demonstrations criterion, because it includes 6 phases with at least 3 data points per phase, the highest possible rating this study could receive would be does not meet WWC SCD standards, given that the data were not organized in such a way as to permit vertical comparisons across cases. Our third example involves a multiple baseline across participants design that includes 8 phases, 1 baseline phase and 1 treatment phase per case, and a minimum of 3 data points per phase. If we then consider the 4 additional multiple baseline or multiple probe criteria, we see that first, baseline data for each case were indeed collected prior to any case receiving the intervention. Second, we can determine that the data presented is indeed organized to permit vertical comparison across the 3 cases, since the figure clearly demonstrates that the timing of the data points was the same for each of the 4 cases. Third, we see that data were indeed gathered immediately upon receipt of the intervention for each case. Fourth, not all cases still in the baseline phase continued baseline measurement at or after the time point when a preceding case first received an intervention probe. Namely, when Case 3 first receives an intervention probe at time 8, Case 4 does not continue baseline measurement at times 8 and 9. Thus, even though this multiple baseline design meets the 3 demonstrations criterion, because it includes 6 phases with at least 3 data points per phase, the highest possible rating this study could receive when considering all phases and all cases would be does not meet WWC SCD standards, given that not all cases in the baseline phase continued their baseline measurements at or after the time point when a preceding case has its first intervention probe. Later, we will discuss how to review experiments which have more phases or cases than the minimum required to meet standards. In addition to the criteria already presented in this module, multiple probe designs also must meet 3 additional criteria, which are essential features related to the internal validity of these specific single case designs. First, multiple probe designs are also required to have vertical overlap in their initial pre-intervention data collection sessions. Within the first 3 observation sessions in the design must include 3 consecutive probe points in order to be eligible to meet WWC SCD standards without reservations, or it must include at least 1 probe point to be eligible to meet WWC SCD standards with reservations. Second, multiple probe designs are also required to have vertical overlap in the data collection sessions immediately preceding introduction of the independent variable. Within the 3 sessions just prior to introducing the independent variable, the design must include 3 consecutive probe points for each case in order to be eligible to meet WWC SCD standards without reservations, or include at least 1 probe point in order to be eligible to meet WWC SCD standards with reservation. Third and finally, each case in a multiple probe design that is not yet receiving the intervention must have a probe point in a session where another case first receives the intervention or the pre-specified intervention criteria if one is articulated in the text of the study. Let us look at several examples and apply the 3 demonstrations criterion and the 4 additional multiple baseline or multiple probe criteria and the 3 additional multiple probe criteria. This figure displays findings from a multiple probe design that includes 6 phases, 1 baseline phase and 1 treatment phase per case, and a minimum of 3 data points per phase. If we assess the 4 additional multiple baseline or multiple probe criteria, we can confirm that the design meets those criteria because 1. Baseline data are collected prior to the intervention for any case, 2. The data are organized in a manner that permits vertical comparison. 3. Intervention phase data are collected immediately on receipt of the intervention for each case. And 4. All cases still in the baseline phase continue baseline measurement at or after the point in which a preceding case first receives an intervention probe. So here, at or after time 4 and time 8. If we then assess the 3 final multiple probe criteria, we see first that the pre-intervention data overlap for at least one probe point in the first 3 observation sessions. Case 1 has a probe point at times 1, 2, and 3, but Case 2 and 3 both only have probe points at times 1 and 2. Thus, all 3 cases have at least one overlapping probe point in the first 3 sessions. Second, there is vertical overlap for at least one probe point immediately prior to the introduction of the independent variable. Namely, Case 1 has a probe point at times 1, 2, and 3, which immediately precedes the introduction of an intervention probe at time 4. Case 2 has one probe point at time 7, immediately preceding the first intervention probe point at time 8. And Case 3 has 2 probe points at times 9 and 10, immediately preceding the first intervention probe point at time 11. Thus, all 3 cases have at least one probe point immediately preceding the first intervention probe point. Third and finally in this example, the design does not meet the criterion that each case not yet receiving the intervention has a probe point in the session where another case first receives the intervention. Namely, Case 3 does not have a baseline probe point at time 8, which is the time at which Case 2 started first receiving the intervention. Thus, even though this multiple baseline design passes the general 3 demonstrations criterion and meets all 4 of the extra criteria for multiple baseline and multiple probe designs, it fails one of the 3 extra criteria for multiple probe designs. For this reason, the highest possible rating this study could receive would be does not meet WWC SCD standards. Here is a second example, which involves a multiple probe design that includes 6 phases, 1 baseline phase and 1 treatment phase per case, and a minimum of 3 data points per phase. If we assess the 4 additional multiple baseline or multiple probe criteria, we can confirm that the design meets those criteria because 1. Baseline data are collected for each case prior to intervention. 2. The data are organized in a manner that permits vertical comparison. 3. Intervention phase data are collected for each case immediately upon receipt of the intervention. And 4. All cases still in the baseline phase continue baseline measurement at or after the point in which a preceding case first receives an intervention probe. So here, at or after time 4 and time 8. If we then assess the 3 final multiple probe criteria, we see first that the pre-intervention data overlap for at least one probe point in the first 3 observation sessions. Case 1 has a probe point at times 1, 2, and 3. Case 2 has initial probe points at times 1 and 2. And Case 3 has a probe point at time 1 and 3. Thus, all 3 cases have at least one overlapping probe point in the first 3 sessions. When we evaluate the second multiple probe criterion, however, we cannot confirm vertical overlap for at least one probe point immediately prior to the introduction of the independent variable. Namely, Case 2 receives its first intervention probe at time 8, but does not have any baseline probe points in the 3 sessions prior to that at times 5, 6, or 7. Although Case 1 and Case 3 both have at least one probe point immediately prior to the introduction of their first intervention probe, since Case 2 does not, this design would not meet the criterion that all cases have at least one probe point immediately preceding their first intervention probe point. Thus, even though this multiple baseline design passes the general 3 demonstrations criterion and meets all 4 of the extra criteria for multiple baseline or multiple probe designs, because it fails one of the 3 extra criteria for multiple probe designs, the highest possible rating this study could receive would be does not meet WWC SCD standards. Now that we have covered the WWC SCD standards and how those are used to determine WWC ratings for single-case design studies, it is important to note that many single-case studies may use designs that have more than the minimum number of phases or data points per phase that are required to meet these standards. For instance, a treatment reversal or withdrawal design that had 6 total phases, say an AB, AB, AB design, would have more than the minimum number of phases required to meet the WWC SCD standards. Another example might be multiple baseline or multiple probe design with 4 or more cases, which would therefore contain 8 or more total phases. Under this scenario, WWC reviewers will also first conduct their review considering all phases and all cases in the design. If the experiment is rated meets WWC SCD standards with or without reservations when considering all phases and cases, the reviewer will complete the review without separately considering subsets of phases or cases from the design. However, if the study is rated does not meet WWC SCD standards when considering all phases and cases in the design, the reviewer will then conduct the review considering any subsets of consecutive phases or consecutive cases with enough data points to determine whether that subset could meet WWC SCD standards. In this latter case, if a subset of phases or cases is the focus of a WWC review, this should always be clearly and transparently documented in the study review guide. Knowledge Check 3. A multiple baseline across participants design with 3 cases reports the following figure. Based on the graph shown here, what is the highest possible rating the study could achieve? Your choices are A. Meets WWC SCD standards without reservations. B. Meets WWC SCD standards with reservations. C. Does not meet WWC SCD standards. You may want to pause the video now to think about your answer. The answer is B. The highest possible rating this study could receive is meets WWC SCD standards with reservations. This multiple baseline design includes 6 phases, and each of those phases includes at least 3 observations per phase. Further, the study passes the 4 additional multiple baseline or multiple probe criteria such that data are collected in each baseline phase prior to the intervention, data presentation permits vertical comparison, data are collected in the intervention phase for each case immediately upon receipt of the intervention, and baseline data collection continues at or after the time when a preceding case first receives an intervention probe. Thus, the highest possible rating this study could receive is meets WWC SCD standards with reservations. Knowledge Check 4. A treatment reversal or withdrawal design with 1 case reports the following figure. Based on the graph shown here, what is the highest possible rating the study could achieve? Your choices are A. Meets WWC SCD standards without reservations. B. Meets WWC SCD standards with reservations. C. Does not meet WWC SCD standards. You may want to pause the video now to think about your answer. Your answer is C. The highest possible rating this study could receive is does not meet WWC SCD standards. Although the design does have the required minimum of 5 data points per phase required to meet WWC SCD standards, the study only has 3 phases, 1 intervention phase and 2 baseline phases. Thus, this design does not have the minimum required 4 phases necessary for meeting WWC SCD standards with or without reservations. Thus, the highest possible rating this study could receive is does not meet WWC SCD standards. This concludes our module on determining study ratings for single case designs. Let's review what we discussed in this module. We described the WWC standards for reviewing evidence from single case design studies, and we demonstrated how to apply the WWC single case design standards to determine a final study rating. The next module in the training series will focus on non-design components that may affect the rating of a study being reviewed under the WWC single case design standards.